They actually understand that we're capable of doing real work, which is why I chose to go to Lichtenstein.
Yeah, it's a lot of ticketing though. A lot of telephone stuff. Do you like VoIP, I hope?
Yeah. I mean, Hartpence are like...
We have like 100 different locations with call manager, so...
I'm excited. We just discovered today that there's a telephony services express setup wizard, which Hartpence purposely neglected to tell us about. It sets up DHCP, TFTP, all the call manager stuff, and it takes like 30 seconds.
Just to make sure. Nathan, we're streaming, so watch what you say now.
We are live.
It's a wonderful wall.
So why am I the one who has to watch this?
Exactly.
I asked him if he was coming tonight.
Oh, yeah.
He's like, no. I was like, why not? Because.
Well, the other day in class, Garrett was like, "Yo, is your club just like Dave's club, but it worked?" And Dave's like,
Except it's not.
I
You
didn't
didn't
hear that.
and Garrett was like, "Sorry, Dave."
Dave's probably watching from
Yes.
Is Dave watching?
Dave has 100%.
Oh, Bruce goes,
We love you.
we've got to speak the room for IEDs.
Shut up.
Yeah, Bruce. IED. So when I was sitting in the atrium before, I saw like this classic, very lost-looking family standing in the atrium. I was like, why are they here at 6 o'clock at night? But like, my tour guide went in. I was like, hi, can I help you? He's like, oh yeah, we're here for some like event for software engineering pursuing for high school kids. And I was just like chatting with my dad. He's like, do you know a guy named Larry Hill per chance? And I was like,
Oh, God.
yes. Why? He's like, oh, you worked with him at Harris. And I was like, dude, all Larry fucking talked about was Harris. I was like,
Are you in that?
Is that all right?
Go there and start talking.
what?
Wait, what?
Someone is watching the live stream. They just texted
Sorry, the
me.
bottom. Oh, look, we got 5 viewers.
5?
Yeah, because I just. One of them is Jeff, so.
I'm one of them.
Okay. Hey, everyone's in this room.
Everybody who's live streaming is actually right here, so they can like text.
Everyone, if you haven't signed in, please do so on the iPad. And then also
Take some
there's free
pizza.
stickers and food, so please take that.
It is officially 7 o'clock, so I'll do an introduction and wait for Hartpence to get here.
What?
I got it. Hey, friendly folks.
10 viewers.
10 viewers. So, hi everyone. In case you don't know me, my name, actually, let's wait 1 second. I'll try to sign this as well because there's no interpreter yet. We have 8 desks. So we're going to try to do this double time. I'm going to wait for him. To be awkward. So, hi everyone. My name is Nathan Lichtenstein. Long last name. I'm a 3rd year networking student. This is our first tech talk, another sign for event here. So we're going to be covering from 7 to 8. Bruce Hartpence right over here. He's going to be talking.
Covering Bruce Hartpence.
Yeah, we're going to be talking about the life and times of Bruce Hartpence. We're going to start with his birth, all the way up through when he invented VoIP. Okay. So that's going to be from 7 until 8. From 8 to 8:20, we're going to talk about Ansible continuous deployment. 8:20 to 8:40, packet crafting with Scapy. And then rounding out the night would be myself with Linux file permissions. If you haven't signed in already on Geoff's iPad at the back, feel free to use and or take it. Last but not least, if you are on our emailing list, good for you. If you are not, go to NextHop.network to subscribe to our emailing list. As I said, my name is Nathan Lichtenstein. I'm the president of this club that student government refuses to acknowledge exists. Joining us as well is Bruce DeWald, the unofficial vice president, and Geoff Kaiser, the unofficial treasurer. On that topic, I will turn the floor over to Professor Hartpence. I know we have to remind you of this, but make sure you project your voice because we're live streaming.
I'll give it a shot, Nathan.
Thank you. And yeah, let's do this.
Hi, everyone.
a small Buckeye child in Ohio.
Ohio. I'm from Ohio.
Whereabouts in Ohio?
Chagrin Falls.
Columbus for me. Although I moved out when I was 5 months old, and so I don't remember very much of it.
Wow. You moved on your own when you were 5 months.
I did not say that. I did have some help.
Moved out.
It's around that time he invented TFTP. You can erase anything.
You just.
Thanks so much. Oh, when have I gone? Dang nabbit, I shall have to take another whack at it. Alright, so let me just get this going here and then we'll chat about what we're going to do. This claims that we're doing what we're supposed to do here.
Hey. I had black screen turned on. I don't know.
Yeah, I thought I just...
Oh.
There we go. Let me do this. Yeah. There we go. Alrighty. Oh, I don't need that. I need this. Alright, I changed a couple slides since I sent it to you. So let's try this again. I'll send you another one. You want to replace it because I forgot I had some. Open flow package. Okay, so I am Bruce Hartpence. For those of you who don't know me, I'm a networking kind of guy. Wired and wireless, do some VoIP stuff, and these guys are joining me this semester for some quality of service and some heavy duty networking. So that's what I do. I love to get in the lab and mess around with stuff. And I am currently working on my PhD, and that is in the area of software defined networking, but it is there's lots of things that go into it. So that's kind of what I'm looking at. So without further ado, this is also happens to be the class that I'm taking, and so you guys are kind of helping me hone my thoughts for this class and my eventual thesis. Okay, but before we start talking about SDN, I want to talk to you guys a little bit about wireless topologies. So we got lots of variations on the wireless topology. Now, why we're talking about wireless when this is supposed to be about SDN, I will explain here in just a minute. But how many of you have taken 242, the wireless class, or the, all right, not, we're real happy about it. You're taking it. All right. So if you think about how 802.11 networks operate, right, you have your basic AP, and the AP has the job of doing what? What are some of the things the AP does? Excellent. The AP sends out a beacon, right, does that. And the AP coordinates the communication within the cell, right? Which means that we've got all the host traffic that the AP's got to forward. The AP is also the connection point between the wired network and the wireless network. The AP does some security stuff if you've got that configured. But the point here is that when you're dealing with an ESS or a BSS, what we might call an infrastructure network, the AP is doing a lot of the work. And if you have an ESS, or even if you have a couple of BSSs that happen to be connected to the same infrastructure, those APs might help each other out, but a lot of times they're doing all the work by themselves. And then there's lots of variations on this, right? They might see each other. We can separate it by quite a bit, and et cetera, et cetera. Okay, so that's kind of wireless topologies. This is what we were just talking about. So the AP has the job of handling all that stuff. Now, if you have what we might call an enterprise environment, or oh, come on in. They're wondering, can we interrupt? I don't know. There's a sign up.
Yeah, we've got free food.
All right. So if you were looking at more of a metropolitan sort of thing, or a campus network, or just a large company network, then you're going to be handing off some of that stuff, right? You might do user-based authentication with a server or something like that. And I'll get to that here in a second. But there's a lot of coordination that's done by the AP. Now, let's pretend for a minute that you're working for ITS. And you want to set up a campus network. And you want to support all of the student needs and desires, which means that I want to put cell phones on the network, and I want to do some high capacity transmissions, and we want to limit the dead zones. And so this is what we're going to do. This is what we're going to do. We are going to sprinkle APs all over the place, right? Sounds pretty good. Sounds pretty good. And then what we're going to do is we're going to say, oh, yeah, by the way, our personnel budget for this is pretty small. So there's like 2 of you. That's the truth. There's Dave and Christine. They run all around all this campus with the help of some students and the occasional little crew that they have. But usually it's like those 2, and they run all over the place. You recognize them as they're going around. Dave's just this big, huge, kind of guy, and Christine is, well, she's not. She's smaller. But they run all over the place. Now, the point that I'm trying to make here is that these people, and even if it was an army of people, even if it was 50 people, how many APs do you suppose it takes to cover RIT? Yeah, it's a lot. So do you want to go out and touch all those? Have to configure them manually? No, not this little mammal. Even if you have configuration management utilities, it's still a lot of work. Okay. So we can do a couple of models here. We can do fat APs, which means that the AP makes all of the decisions, does all of the handling of the traffic, does all of the access control, does all of the encryption, maybe quality of service, because the APs that we have will do 802.11e, right? We have A, B, G, N, A, C, A, D. Those are transmission standards, but we have all these other standards that are in the 802.11 realm, E, F, I, that have to do with how the thing operates. So they can do a lot of stuff. Now you can do thin APs, and this starts to get us where we want to go. Thin APs don't make any of these decisions. But then the question is, if the AP is not making the decisions, who is? Right? Where do we pass those off to? So what we're going to do is we're going to manage them from one central location. And this gets us in the direction that we want to eventually get to for software-defined networking. Okay. So if you come up against the controller lab, all right, or labs, by the way, I'll just put this out there. I made a couple of how-to videos on it. So if you get stuck, go to YouTube. I did it from scratch. Here's how you build it, okay? So the controllers are a bear. There's a lot to be done there. And so the point that I'll sort of put over here, I'll just leave it here, okay, is that if you wanted to do advanced networking stuff, there's a whole bunch of other stuff you have to know before you do advanced stuff. For example, if I say VLANs to you and you go, huh? Then you're not ready for SDN, nor are you ready for controllers. If I say trunks and you go, I've heard of those, you're not ready yet. You have to have a really good handle on VLANs and trunks. If I say, what we're going to do is we're going to build our production network and then we're going to build an overlay network, and you go, overlay? And I say, yeah, and on that overlay network, we're going to make it a management network that's going to be on separate IP addressing, separate VLANs, maybe even separate protocols, loopback interfaces, bridge virtual interfaces, management VLANs, oh my. And you go, what? You're not ready, right? You have to bone up on that stuff. You have to get ready for that stuff. You have to spend some time. All right. Now the controller is that central point. The magic number is 2, right? At a minimum, when you build a controller-based thin AP environment, you're going to have 2 VLANs, 2 networks, 2 types of management interface. So there's and then you're going to have to VLAN all that up and trunk it out to the nodes themselves, to the APs, and to the controller. Okay, so you have management interfaces all over the place. One for the AP manager, one for the management console to the controller itself. You've got subnets for the host. You've got that management subnet for the APs. You got 2 DHCP scopes, one for the hosts, one for the APs. Magic number is 2. But here's the cool thing, right? So host connects to this AP. The AP goes, I don't know what's going on. Hold on a sec. Let me talk to the controller, get my config. Then the node connects to the AP. The AP says, hold on, let me talk to the controller. Is this guy okay to join the network? Looks like you're okay. All right, you're good. I'll let your traffic into the network, and I'll tunnel all that. Huh? What? Tunneling? I'll tunnel all that back to the controller, and he'll figure out what to do with it and then pass it on. Right? So there's this whole complicated, involved architecture the minute you go to controllers. But that's exactly what software-defined networking is doing. So the reason I start with wireless is that if you get your hands wrapped around how wireless networks work, right, the basic operation, then you get to the controllers and you go, you know, it was hard. I suffered through it and I got it, and I think I got a handle on this controller architecture. Then software-defined networking is not much more of a leap from there. So software-defined networking is this mystical, magical thing. Oh, software-defined networking, what's that? It sounds crazy. Network functions virtualization, ooh, ah. But we've seen the architecture before. We've seen the use case for it. And the best example that we have is those wireless controllers and that whole model, okay? Now this is our deployment, right? We got this PoE switch, right? Power over Ethernet switch. It's usually a 3560 or a 3550. And then you got the controller outside. But in the larger Cisco chassis that we have around here, the controller is just a blade inside the chassis. So it can sit anywhere. And the same is true when you get to software-defined networking. This can be an outside box, or it can be a VM somewhere. Okay? All right. Everybody good? Questions so far? No? By the way, if you get to that controller lab and you just fail open, come see me. Okay? All right. So this is another idea that we sort of have to get out there. How are decisions made? If you survived 241 and 242, and maybe advanced routing and switching, you're getting used to things like this. I want to get to a web server, so my host has a what on it? How does a host make decisions? It's got a routing table. Anything else? It's got DNS, okay. It's got a gateway. All of that stuff is going to be accessed after I get to my routing table. We've got an ARP table in there too, right? So networking is really about tables. When I get up to an access point, I've got a forwarding information base, and I've got my association table. If it's got an IP address, it's got an ARP table. We get to the SAT, right? I've got, that's the source address table, or what we call CAN, or the list of all the MAC addresses on the ports. If it's got an IP address, then it's also got a routing table and an ARP table. And then, of course, we go to the router, we got the same thing. Okay. Now, this little arrow here is designed not only to say, look, that's how I get to the web server. See, it's plainly labeled over there. But I want to just put a word out there that I want you to remember. It's flow. Flow is the word. Okay. We don't really, well, I won't say it that way. I will say that something's been hidden from you. We have given you all this information, and you have learned it, and you're able to build things and all that. But the reality is that when something gets inside one of these boxes, the thing that's actually examined is something called a flow table. Okay? So when we start building software switches for SDN, software routers for SDN, it's really all about the flows. So flow becomes a key word and tricky phrase for us. And to make matters worse, we've got micro flows and macro flows. It gets really nutty. But a flow is the thing. And a flow is a set of packets going from a source to a destination. Okay? One way. So if they're coming back to me, I actually have two flows. I got them going that way, and I got them coming back this way. Now, a micro flow, forget that. Never mind. We're not even going to talk about that. Okay, so you guys have your hands wrapped around all this stuff. So you're getting there. So you kind of go, okay, so Hartpence says, yeah, we know stuff, and then, oh, by the way, there's this flow thing out there. Okay, packets going between source and destination. I think I got my hands wrapped around that. Pretty cool. So if you think about it for a sec, and you think about a routing table entry, you think about entries in source address tables, couldn't you sort of imagine a set of flows that was identified as going between two MAC addresses? Right? If I'm talking to you, there's a lot of ways that we could classify the conversation. I could say, you, right there. You got a P code? I got a P code.
Cool.
This is what we're going to do. We're going to send traffic between P code guys. I'm going to send you some traffic. You're going to send me some traffic. And we're going to identify our traffic by P codes. Okay, we can do that. You happen to be wearing spectacles. So here's what we could do. Since I happen to be wearing spectacles too. We could identify this flow as not only going between P code guys, but P code guys that are equipped with spectacles. Now, so what? What did we do? We just added two other sets of details. But what we're identifying also is that maybe if he happened to be wearing a P code, this isn't really for him. You know? The other conversation between P code guys might have been for him. But P code guys with glasses, well, that's you and me, brother, right? So that's one of the ways that we can separate out the details for the flows. Those ideas are called tuples or tuples, depending on how you want to pronounce it. This here. Okay. Turns out that we have lots of uses for these guys here. Sometimes they're in networking, sometimes they're in programming, but it's characteristics that we're looking at here. All right. So, another big part of this question is where is the intelligence? Where's the brains? Well, if it's a fat AP, some of the brains are right there. Does a switch go to anybody else for its decisions in the SAT? No. All the decisions right there. All the intelligence is right there. Router, same thing. But the controller model says that I've got a whole bunch of these guys, and the intelligence is not in this device. The intelligence is in a controller, a centralized point, and I'm going to send it all up there and make the decision. So what I'm going to suggest to you here is that with software-defined networking, we're going to remove those kinds of decisions from all those devices, and we're going to have a way to centralize it. Okay? Now, there's a lot of reasons that we might want to do that. We'll talk about those here in a little bit. By the way, are there any weaknesses in that sort of model? Is there anything that you say, well, okay, so you want to centralize all the decisions way out here? Any weaknesses in this? Single point of failure, there's one.
Single point of failure.
Okay. You know, I like the way you guys think. You're simpatico back there. Okay, so let's talk about the single point of failure just for a second. What could happen to make us realize that single point of failure? Huh? Yeah. Bad nick.
Cut line.
Oh, do you need that cable? Sorry about that. Let me plug that back in there for you. Power loss. How about some of the more nefarious things that our friends in computer security might be up to? It could be a DOS, right? It could be some kind of man in the middle. There's just all kinds of things that could happen to this. Now, we might be a little protected because we might put that on a management network that can't be routed. It'll be in a VM that's behind a VLAN somewhere. But, you know, if you can get to it, maybe we can disrupt service. So that's a problem. Let's forget about security or single point of failure. Anything else? What if I said to you, listen, I know you're here at RIT, and I know you got a couple of bucks to spend. But your students, you don't have a lot of bucks. But let's say that I added this requirement to you as well. I said, before you spend any money, you got to call your mom or dad. Call somebody in your family, get approval for it. Can't spend anything. I mean, nothing. Not vending machine, not pizza, movies, nothing. What do you think that does to you? Besides being annoying.
It's a lot of traffic back and forth.
Yeah. So here's mom or dad right here, or grandma, right? And so here's you. Well, we'll put you there. Yeah.
I suspect it could possibly also create a bottleneck in your network.
Yeah, it's a huge bottleneck, right? I'm going to send all this traffic up here. Decisions are going to get made, and then they're going to go back here, and then thumbs up, thumbs down. And not only that, we're going to deal with a bunch of devices. So we have quality of service, we've got latency stuff, all kinds of things. Now this is a really simple diagram. And you kind of go, what's the big deal? You know, I know that on the switches that I looked at, that's gig. Put a nice big fat processor in there, some good memory, let's go get them. What's the big deal? Well, let's say that it's 50 or 100 or 500 APs. And oh, by the way, how many of you are wired right now? None of you. So all the traffic is wireless, and all of it's going to be piped up to that controller. And now you got to go, oh, right, yeah, I guess that might be a problem. All right. So there are some issues associated with having that centralized point. And then we can add some stuff onto this, right? We can add some monitoring. In addition to the controller or the FAT AP model, whichever one you're going to adhere to, we might have some additional requirements for the node. We might be doing SNMP, we might do some authentication, right? So if you guys have a domain you're logging into or something like that. Okay. All right, we good so far? Okay. We kind of talked about this. The controller is also a DHCP server, so all of that stuff is happening. So the controller's dead, you don't even get an IP address. These are the protocols that are used. CapWAP is the one that you're likely to see on the controllers here for controlling the AP. So that's why I just put those there. Okay. So this is what we wind up with. You got, so I said 2 was the magic number. You've got a VLAN and an IP subnet for the host. You have a VLAN and an IP subnet for the management interfaces associated with the APs, the AP manager, and the management interface. So VLAN, subnet, and then a DHCP scope. And all of this stuff has to go out this one pipe here. So you got to get to it. So out here, you're sitting out here. You could be consoled in, but a lot of times you're out here with an IP address managing the whole thing externally, right? Okay. So this model is becoming more and more common, and especially when you start talking about enterprises, data centers, all those kinds of things. They're looking for these economies of scale. How do I manage in one particular location? All right, so that's more about wireless stuff, right? If you have all this stuff going up to the controller, and wireless speeds are getting faster, you got to have this pretty big pipe going up to the controller and away from the switch. So this is right out of the documentation. Anybody remember this? Anybody seen this? Yeah. So this is a happy diagram, right? How the heck do you make heads or tails of this? Well, here is, so I'll just give you the quick and dirty on it, right? This one here is the service port, so forget about this. That's the one port going down to the switch. So the controller goes to the switch, and running over this one physical interface, we have the AP manager and the management interface. Same subnet, same VLAN, 2 different things you're talking to. This controls the APs, this controls the controller, right? So they're the same one. So what's all this stuff? Well, these are just instances of the same thing. So let's forget about the purple and the red here. And we'll just go with that green one up top there. It's the VLAN and the subnet and the DHCP scope for those hosts that are out here. And that's it. So when I say the magic number is 2, well, we got this blue one and we have the green one. That's it. Now you can have more. But for what you need to get done and to understand what's going on here, you really just need 2. Okay? So that is, I think that's actually in the lab, and that is from the Cisco documentation, so that's what you actually see. So there's just the complexity of the controller. Lots of fun. All right. So we got our hands wrapped around the controller model. You guys all with me? Right? We've seen it before, or I'm about to see it if I'm doing 242, right? In 3-4 weeks, I'm going to be there. All right, so forget about wireless and controllers here for a second. We have an IEEE working group right here. So in 10 years, 15 years, you might actually see an IEEE standard coming out of RIT. Sounds pretty cool. So we got an IEEE working group. And the idea of the working group is that it's a competitor to rapid spanning tree and something called shortest path bridging. So this is me and Nirmala Shenoy and Daryl Johnson and Bill Stackpole, and we've been fooling around with it for about 2 years now. It's just a couple of the ideas here, right? You guys, how many of you know and understand spanning tree? Rapid spanning tree, right? So you're good. So loops are bad, right? We don't like loops. However, the minute you kill off loops, you killed off redundancy. So we're trying to say, well, maybe there's a way to kill off loops and have redundancy. And oh, by the way, instead of, wouldn't it be really cool, wouldn't it be awesome if, I'll leave your agenda up there. Wouldn't it be really cool if I could say, well, in a rinky-dink little topology here, right? If this is my root up here, I might block that guy right there. Which means that hosts X and Y, if they were connected in this topology, they'd have to go all the way up and around, right? That's the problem with rapid spanning tree and spanning tree. Wouldn't it be kind of cool if, even though this link was blocked, if we somehow knew that they were neighbors and we just sent it directly to them? So that's another idea. Sounds pretty good. I know. Let me know. It sounds pretty good, right? Right? Yeah? Awesome? Okay, good. So that's all I wanted. I'm a little needy, but that's all right. So we have what could be installed in switches across the industry. We could theoretically have that. The question is, even if we have the best standard ever written, we could. It's possible. We could. What do we do? So this is what we'll do. We'll test it. We will we'll simulate it. How many OpNet people we got here? Right? Isn't OpNet fun? It's fun, right?
Great.
It's a rocking good time. All right. Are there any problems with simulation?
Yes.
Lay it out for me.
Simulations are pretty close to actual data, but you can't get 100% accurate data to perform a simulation without using other factors.
Yeah, so this weekend I was watching some old boxing matches with Muhammad Ali. So this is what we're going to do. I'm going to train you guys to fight Muhammad Ali. And what we're going to do is we're going to, we're going to simulate actual boxing conditions. So I'm going to get boxing gloves. We'll put them on you. We'll get a little shadow boxing going on. We'll kind of bob and weave with each other. Hey, ho, ho. But we're simulating. So, I can't actually have Muhammad Ali swinging at you, right? Until you're in the match with Muhammad Ali. Do you feel prepared? I do not either. So I'm with you. We're in the same boat, right? So that's the problem with simulation. You can throw in as many variables as you want. And OpNet can throw traffic. It has a traffic generator. You can do stuff. But it's never quite the real thing, right? You're in a flight simulator. And I'll put you in a cockpit of a 747. Are you ready? No. So there are differences. Okay, so that's a limitation. Here's what we'll do. Instead of simulation, or after we're done, we're satisfied with the simulation, we'll build a test bed. So what we're going to do is we're going to take a whole bunch of Linux hosts. We're going to take the bridging module, and we're going to write the C code for it, which we're actually doing. Write the C code for it, and change the operation. We're going to replace all of the spanning tree stuff that it might do, and put our own code in so that it does mesh tree bridging instead. Sounds pretty good. So now it's actually running on the network. We can hook the nodes up to each other with multiple NICs, or we can throw in hubs. Now, normally we wouldn't do this, right? But if we throw in switches, well, then they're doing spanning tree. So we'd probably, because hubs are for neophytes, right? We will probably put lots of NICs in there. We'll bridge everything together. Okay. Any problems with that?
Scale.
All right. So I got a problem with scale. All right. What I'm going to do is we're going to build also a computer that can we can put like 100 NICs in it. So the scale issue, that's gone. Did I kill off all the problems? You guys are shaking. What do you mean I didn't kill off all the problems? What are you talking about?
Be able to simulate traffic now on a real network.
Oh, right. So even if we could build this mystical, magical computer, we have a problem. It's not real traffic. So if I say, we've got this mesh tree protocol, and no matter what you throw at it, no matter what topology, it's going to work. And then Cisco is going to come along and say, that sounds pretty good. We would like to put your protocol in our switches. Juniper, same thing. They're in the same room. They're going, sounds good. You Cisco? Yeah, Juniper. Let's do this. We need some data. What have you guys done so far? Well, this is what we did. We put it in a test bed. We rewrote the Linux kernel to add the additional modules, and we pinged everywhere. Oh, yeah! And he's going to say, so how much traffic? We pinged up to like 50,000 bytes per ICMP echo requests. How many nodes? Yeah, we had like 12. Yeah. And they're going to say, here's the door, and there you go, off you go. Because we have got nowhere near the scaling or the amount of traffic that we actually get. So this is what we'll do. Okay, so the next step is VLANs. So how many of you, if I said to you, this is actually what I was doing in the lab the other day, if I said to you, I want you to test RIP and OSPF on the same topology, how would you do it? Try one, then the other. Yeah, so you could build the entire topology and rip it up, do all your tests, and then reconfigure all the routers to do OSPF. And that would work. But what if I said, I'd like to see some side-by-side comparisons. Make sure we are testing all the variables at the same time. Then what you might do is you say, okay, cool, I'll put some routers in one VLAN, and I'll put routers in another VLAN, and we'll test them at the same time. So, over the same physical topology, you can set up more than one logical topology. Is everybody with me? That's one of the beautiful things about VLANs. Okay? One of the beautiful things about VLANs is that ability to separate logical topologies. If you have, in rapid spanning tree, you can actually have more than one root, different roots for each VLAN. So each logical topology, each VLAN can have a different logical breaking point, different port that's blocked. So I might have this topology that actually looks like that, right, logically. If I make this guy the root for the red VLAN, then the topology might actually look like that. So since we're switches, we'll do that. Okay. So two different logical topologies on the same physical topology. Pretty cool stuff. So this is what we're going to do. We're going to try to get that scale thing by building over the campus network a different logical topology. So what we have to do is we get a VLAN, and then we plug our Linux nodes into this VLAN and let them do their thing. Sound good? Does that solve all of our problems? Nathan, you're killing me. Every time I solve the problem, you say you haven't solved it. What haven't I done yet?
Generated traffic.
Yeah, I still don't have the traffic. Great, it's running on the campus stuff now. But is the campus traffic going through my Linux boxes? No, it still doesn't work. Man, so what are we going to do? I don't know. So here's the deal. This is such a pain that it takes forever to get into a commercial deployment. The current model for getting a protocol or standard out there, it takes like 10 years to get it into a vendor chassis. So that's our product life cycle. So this is what we're going to do. This is what we're going to solve. I'm going to solve your problem. You won't be able to say anything anymore. You won't be able to say anything anymore. This is what we're going to do. I'm going to go to ITS.
Oh, yeah.
And I'm going to say to ITS, this is what we're going to do. Trust me, it'll be fine. All I want to do is modify the production routers and switches for our test. It'll be fine. We've tested it. We've done simulation. We've done it in the lab. We just want to test it so we can get some real data, and then Cisco will buy our stuff, and we'll be millionaires. And we'll be famed in song and story. Everybody read IEEE standards from here on out. We'll see the four of us in there. What is ITS going to say? Are you stoned? Right? This is our production network. You're not touching our production network. We'll say, it'll be fine. They'll say, no, don't touch our keyboard. Stay away from our machinery. Fine. And the problem is that, of course, the experiment would affect everybody then. We would get user data, but if we made any mistakes, our experiment is toast, and so is the whole network. All right, so we can't do that either. That's the end of the rest of you. So this is one of the places that SDN is really shows some great promise. So traditional network design has some really obvious and straightforward problems. One is that it's static. How many of you have taken a network design class? All right, how many of you are going to take a network design class? Here's the deal, right? You go out, one of the biggest tasks in network design is to do investigation. You have to actually talk to people. You have to find out what they're running, what they want to be able to run, what the current network is doing. You're trying to understand the applications, the devices that are out there, where do they want to be. A lot of investigation, a lot of work, a lot of walking around, you wear out some shoe leather. And so what happens is you make a design. You get it approved, you get the budget for it, you get your project out there, and you do the design. You install it, configure it, get it ready. Boom! Maybe have a feedback loop in there and make sure you covered all your bases. And you say, okay, we did our design, we've deployed it, we've tested it, everything looks pretty good. See ya. And you go away for 5-8 years until there is a need for you to come back and revisit the design process again. That's a problem. Because the network is very, very static, and it's a very, very manual process. How many times do you see ITS manipulating routers and configs around here? It happens on occasion, but usually something's gone wrong, or something major has to be changed. Very static. Okay? But this also means that, the network works, we're not going to touch it. So the network is not there to support any research, any projects, anything cool, anything fun. Nobody is ever going to say of a network design team that they're adaptive, that they're quick on their feet. Nobody's ever going to say that, because network design teams are there to make the network operate, and then don't touch it. It works. Right? Don't touch it. Now, let's say that there's some major change that comes up. For us, the biggest change is VMs. Everybody wants to do virtualization. Everybody wants to do cloud. So that's a huge thing right now. Everything's going to go after the data center. But you could easily argue that voice over IP and wireless represent huge changes as well. So that network design that you thought was going to live forever, we have these fairly rapid changes. And everything else changes with the whims of the users, not the network design, though. Okay. So the buzzword with network design is it's ossifying. Right? It's like petrified forest. It just doesn't do anything anymore. It just you build it, you don't touch it, you walk away. Okay. If you compare that to everything else changes. Our software changes. What you're going to keep up with, the things that you want to do with the network, the people you want to talk to, where your data, everything else changes, but not the network design. And these are just a couple of examples. Okay, everything else adapts to the way that we do things. And then we're back to this. So okay, we've learned from this. Yes, websites know everything, and we've got smart applications, and we've got mobile computing, and all this other stuff. Let's change the way that we do networks. No, we're not going to do that. We're still going to keep the same model. Okay. So there's lots of technologies that go into this whole software-defined networking model. I mentioned VLANs and trunks, but virtualization becomes a really, really important part of this. So how many of you feel pretty hip on desktop virtualization? Pretty good? You're nervous. I see you. I don't know. I think I am. What's he going to say? I don't know. Well, I know the answer. So generally speaking, when we talk about virtualization, the first stop is what we call desktop virtualization, right? I have a computer, I'm running VMware Workstation or VirtualBox, and I spin up a couple of VMs and I get them to talk to each other and life's good. That's desktop virtualization. You could say that if I'm going to run a server, I've just done server virtualization, but that's usually tied to a different kind of hypervisor. So we have type 1 and type 2 hypervisors. The next step up is the bare metal hypervisor, and it's where we're going to do something like ESX or KVM. How many of you have done an ESX install? Good bunch of you, okay. So now we got all the management issues associated with it. So now if I say to you, we're going to take your virtualization environment, and now we're going to run virtual switches and virtual routers, and all your VMs are going to be in there, and oh, by the way, we're going to stick one of those controller thingies out there. Now you're heading down the road of SDN. And in fact, if you've done an ESX install, you know that ESX comes with a virtual switch, right? There's a virtual switch in there. What I'm going to suggest is that you're going to take that virtual switch and actually connect it to a real dyed-in-the-wool virtual switch, something called Open vSwitch. It's an actual huge product, or OVS for short, which you're actually going to use to build your networks. Okay. So there's lots of what we might call synergistic activities or synergistic ideas, and SDN is a way to get you to sort of put all that stuff together and get it all talking. So that's the real struggle. If you got an ESX environment and you are able to get VMs in different virtual networks through the vSwitch or multiple vSwitches talking to nodes on the outside, you're in pretty good shape. That is, I don't think I'm overstating it when I say that's a monster skill. If you get VLANs, trunks, virtual switching, bare metal hypervisors, VM nets, and how to connect them to the rest of the world, give yourself a pat on the back. That's some good stuff right there. Okay. Now, just to give you just a quick thing on the SDN roots. SDN, as an idea, has not been around that long. 2006 to 2008, there were papers coming out of Stanford. In fact, if you want to look at network research, Stanford is huge on all this. So you just look at anything, Google Scholar, anything coming out of Stanford. So they're a really good bunch out there, and these are just some of the big names associated with it, especially the bottom three. But the guy up there at the top is, he's not far behind them. Now, what we've been talking about, or what I've been talking about, is this idea of intelligence. Where is the intelligence for the network going to lie? It's going to be removed somewhere. Whether it's virtually removed or physically removed, it's removed somewhere. But this idea has been around a long time. The telco network has an intelligence in the overlay network. Decisions get made, and then you get to make phone calls. There's an intelligence network, smart routing protocols, and the ability to configure routers on the fly in the middle of an active topology. So there's a lot of ideas about injecting intelligence into the network. But on data networks, they've never really held up until SDN started to pop up here. So what we're talking about now is some of the most recent developments in SDN. Okay, some of the biggest ideas. Yeah, we kind of already talked about this. All right. So, planes. There are. It's not bad. It's not bad. There are, generally speaking, in the traditional model, two planes. There's the data plane and the control plane. So what ends up happening, you got a switch or a router, you console into it, you SSH into it, and you configure that box. You just configured the control plane. And then you walk away, and it does its thing. The control plane decides what's going to happen with traffic. The data plane is just the user traffic flowing across there. Sometimes it's the management traffic if you're doing SNMP or something like that. Okay. Stuff that flows on the data plane is also what we call east-west traffic. The management plane is something new. So this whole idea of you touching the control plane and then walking away for a second, for that instant in time while you were configuring it, you were the management plane. So next time in your lab, just do this. Just stand over the switch and go, and they'll ask you what you're doing. You go, I am the management plane, baby. In SDN, we're going to make that a more permanent fixture. That's where the controller is. So we're going to pull that management plane out and we're going to make it resident there. It's virtually resident, but it's resident. So now we're going to establish this link up between the control plane and the management plane that doesn't die. That is what we call a north-south bound connection. How are we doing on time? You okay?
Yeah, we're doing
Okay. All right. So this is what we get with the idea of plane separation. We're going to pull this guy out. Okay? And again, that just brings us back to the controller model. And so what we're going to do with the management plane is we're going to try to instantiate flows in the flow table of the control plane of the devices that are managed by the management plane. There we go. That's the whole object of the exercise. Oops. So, from a logical perspective, we've got our software switch, okay, and then our network node. So we've got this sort of east-west thing. But before any east-west stuff can happen, we've got this north-south bound communication that has to occur. So what happens is the traffic comes in, and we have to make those decisions on it the same way that we did in the wireless model. Okay? Everybody good still? All right. So in this case, because we're going to take the ideas that we had in wireless, and we're just going to adapt them for what's happening right now. So the management plane is out there on the controller. So I'm going to use the word network element, but network element in this case most commonly refers to the switch, but you might be doing this with a router or a firewall, doing deep packet inspection, any of those things. Okay? So the network devices receive the traffic from the host, and when that happens, they have to decide what to do with it. Well, they don't have any control yet because they haven't been configured. So the network devices ask the controller if the flow is okay or if we can set this up. Now it might be we're going to set it up based on MAC addresses, IP addresses, P codes and glasses. It might mean that we're going to go by ports, application. It might be all of those things. So here's the other really big term associated with SDN. And that is that the network devices, the elements, are going to communicate with the controller via a new protocol called OpenFlow. Now OpenFlow, again, has been around since 2006, 2008. Still under development. It's only in version 1.3, but it's coming out into 2 soon. And a lot of this stuff can actually be understood by Wireshark. So if you can get in between the controller and the network element, you can actually see the OpenFlow protocol going back and forth. So OpenFlow is a really important word. Now this is a more complex graphic, obviously. I prefer this one. But this just shows you, this is the actual, so here's our network elements, or our device, right? And here's the control plane that we've got talking to the devices. Here's our controller, and then there's our applications, whatever they might be. Now, those guys right there, up there, might be the reason that you're configuring this, okay? So here's our management plane, our admin plane. And that's pretty much how it works. And then your data flows go across it. A little tougher to see what's happening there, but that is right out of the Open Networking Foundation. Okay, so OpenFlow messaging. OpenFlow is a client-server based protocol. So that means that the switches, as one example, talk to the controller just like anything else that you've seen. They use ports 6633 and 6634, and they communicate back and forth via this OpenFlow protocol. So this is just a really simple hello message, right? This happens to be a version 1 of the OpenFlow protocol. So they find each other. And then they have a keep alive that goes along with it. And then this is just an example of management traffic that's flowing back and forth. So here is this, I just did a ping in between here, and then here's the connection to establish the connectivity between the controllers and the network element. Now in this case, the controller happened to be on the same VM as the switch, but a lot of times I like to separate them in two different VLANs or VMs so that you can see a lot more of the traffic. I always thought it was harder to see what was going on if you did everything inside the VM, so I like to split them out sometimes. Okay, so here is what happens when packets come into the network element, right? So now these nodes go, I want to do stuff. I want to ping in this case. This might also be, you've got an ARP in here as well. So this is what they want to do. So the network element, yeah, 5 minutes? 5 minutes. But I'm so excited. So now I'm all nervous. What am I going to get to? All right, so this is a flow mod message. So the minute something has to happen, the minute we have to install something in the flow table, we've got to do a mod message, and then we're going to start doing entries in the table. But only if the controller says it's okay. Now, I will probably leave it here in case you guys have any questions. But here's the deal, right? I went through that whole thing on what would we do if we had an IEEE standard that we wanted to test. One of the big promises of SDN is, okay, separate out the control plane and the management plane, stick it out there, and you got this pervasive thing that actually is a single point of failure. What's the big deal? What are you doing? But one of the promises of SDN is so that I can have a production network with actual traffic on it that I can test things on and get into some rapid prototyping and things like that. So it's really about finding things out and testing things and tweaking things and see how things run. But if I've got one controller managing the control plane, don't I have the exact same thing that I have now? So what we want to do is figure out a way to cordon off resources. So another part of this is you got to start in something called FlowVisor. So we have FlowVisor says I'm actually going to insert myself in between controllers and chop up the resources of my switch here so that each one of the controllers gets a part of the resources. The controllers don't even know the FlowVisor is there. They're only given a certain portion of it. So that's how we sort of close up the whole thing. So the network becomes much more dynamic because it's got a controller. It is able to respond to changes in what users want to do and update flow tables much more quickly. It enables the network functions virtualization because you can create VMs and applications that use SDN any way you want to, and then this allows us to actually break up the resources, okay? All right. These are some of the big things that are happening in the networking world, at least on the open source side. But every vendor out there does an SDN thing. You can't, any of you subscribe to techie newsletters? None of you? Kinda. How was that kind of? I get them, but I don't read them. Subscribe. Find out what's happening out there. I mean, there's just piles. They're free. They clog up your inbox, but you find out what's going on. If you're at all interested in this stuff, get involved in like I don't want to say get involved in a dev email distribution list because then you'll really clog your email. But get in like a discuss thread or something like that, just to see what the big folks are doing out there. Lots and lots of stuff going on in networking world. I mean, it's for a long time it's been sort of static, and now it's kind of fun, kind of lots of stuff happening. All right, I will stop right there. I've been yammering at you guys for a while. Does anybody have any questions about wireless or about SDN or virtualization or anything? Yeah.
You seen the stuff that Facebook's doing with their open switches?
I have read a couple of articles about Facebook doing a bunch of things. One is they're releasing their data, so that's kind of cool. But Facebook and Google and LinkedIn, they're huge for their data centers and their own algorithms and everything else. And Google actually has the one that's in my head right now because they're doing the FlowVisor stuff too. So yeah, it's way cool. way cool. I mean, can you imagine trying to run Facebook's data center? Yeah. And so I went to a talk 2 weeks ago, and they said that if you know data science, that is data about the data, and then data about the data that's about the data, you can write your own thing. These guys get paid like rock star money, $1 million a year to parse through all the data that's being generated on these social media sites. So that's another thing, big data and all that stuff. Whew. Any other questions? Yeah.
So during your research of this IEEE standard, this spawned your research into SDN? Like your interest in researching the SDN option?
Well, I'm not sure what came first. So the
It's a chicken or an egg question.
yeah. So I kind of said I wanted to do more stuff. Here's what I kept running into, gang. So as a networking kind of guy, you say, well, I'm going to learn how to route. So you learn how to static route, and you go, this is not good enough. I think I'll learn a routing protocol. So you learn routing, you learn RIP or OSPF, and you say, my God, that's just not enough. Give me BGP. And then you say, cool, I got BGP. What's next? There's nothing else. Well, it's just not enough. Well, I can write my own. No, I can't write my own. I don't know how to do the coding for that. That's really hard. The algorithms behind it. So I kept running into two walls. I haven't programmed in a long time, and it's been a long time. I mean, I'm an old guy. I'm 51. So it's been a long time since I sat in a math class, sat in a programming class. So what I kept running into is, I can't do this. So my life became, let's learn how somebody else is doing something. Let's learn another protocol. Let's learn another standard. And I was kind of going, it got kind of dull. So that's kind of what headed me off into what's happening now. And yeah, you get tied in with people and you go, wow, that guy's got a really big brain. Or, geez, look at the size of her head. How much gray matter does she have in there? And you go, wow. So, I mean, Jennifer Rexford is a really good example. She's leading the Open Networking Foundation. So you go, what do you have packed in there? I mean, I just go, wow. So I don't know if that answers your question, but. Yeah.
Question from the live stream.
You have people on the live stream.
Yeah,
That's
how
awesome.
many people? Peaked at 15. We're at 10 currently. What do you think of virtualization platforms like GNS3 for testing new topologies and technologies?
Well, I've never used GNS3. I just know the rumors about it. So here's the fun thing about GNS3. Cisco says, we've got to sue them. They're taking our images and they're creating an environment by which people can build Cisco configs, and that's just not right. By the way, if you go into the Cisco testing lab, you will find GNS3. So it's a really good environment. It loads up an image and does what you want it to. And if you don't have the chassis, GNS3, yeah. I mean, there's the licensing concern. You have to worry about that, but yeah. Well, you guys want to go? There's pizza back there. I thank you. I hope that you enjoyed the talk.
All right. Who's up next?
Yeah. And in the meantime, while setting up, again, if you haven't signed in, please do so on the iPad. And again, food and free stickers back there. So yes.
There are stickers. So
I think you present your Oh yeah, I was like, I'll take a picture.
All right. You have the gun.
I want to take a picture of the group from the front, but
yeah.
pasties?
Well, since a virtual so the short answer is yes. I think white box is when you want to do something new to support specific. But that takes a long time to develop and they're much more expensive. So white box will see eventually boxes will get fast enough.
Oh no, just went. Not receiving any data. Don't worry.
7 hours.
We should have a viewing party.
We should all wear washers and masks.
I'm up on all the seasons. If Matt likes it, we can all just works. And he makes it. He doesn't do the microphone stuff. Yeah.
Alrighty, we're gonna get on started again, so we can boogie on down. Send anyone?
He's like, oh, maybe you can change it and we can just do like this week. I'm like, it's not a thing. It's okay. Oh, sorry.
Good.
Geoff.
He asked, he's like, who's Geoff?
That's up there with my favorite. That's up there with my favorite Geoff guys. The question of also, how do you do right on the stick? And this is like 2 weeks ago.
Not on a stage.
Really?
Turn on the rack. Everything's all new. I was like, why do I have no lights? Like, nothing's happening. Yeah. Yep.
Alright.
Okay, I guess I'll get started. My name's Geoff. I'm a fourth year applied networking admin major. I've been working on campus at ITS for like a year or two now. I also do IT stuff for a club on campus, our IT electric vehicle team. Those two are kind of what led into learning Ansible and then doing continuous deployment. Does anybody have any experience with any configuration management programs or frameworks? Okay, neat. This is probably the easiest one to learn. Ansible is a configuration management, config management and orchestration. I don't know if it's framework or something else. Some other stuffs like it are Puppet, Chef, Salt. Ansible is a lot simpler than all the other ones. It's pretty much written in plain English. Salt's probably the next easiest one to learn. It's written in Python and it's agentless, so you just need to use get SSH keys set up and you can start configuring hosts, deploying stuff. Everything is organized into plays and playbooks. Plays are like the individual tasks that you do. Playbooks are groups of those individual things all together. I'll show what it looks like in a second. Everything's executed mostly in order unless you do like includes statements or anything else like that, or includes other things that aren't in the normal order of execution. And then everything's written in YAML, so it's pretty much English. You can read through and see exactly what it's doing. This is what a simple playbook looks like. The top screen is the site.yaml. It describes a few roles that are collections of plays, so you can for better organization. The lower one's an individual play. It's just installing a few packages from Yum. There's a comment. You can organize them into however you want. Everything's just done in like a folder structure. I can show that in a second. Everything's one single command, and then everything's in a folder structure, and it's pretty. It'll make more sense once I show it. The inventories for everything is just a simple INI file, so everything it looks just like that. The lower half of the screen. You can group stuff by a couple different ways. Use some wildcards in there, so you don't have to type out every individual host. There's also some custom inventory plugins, so you can connect into AWS. I think vSphere. I'm not sure if there's an inventory one for that. a couple different things. And then it's also apparently really easy to just build your own module for it, so you can just connect into whatever you've got. I haven't looked to see if there's anything for like AD or anything else like that, but it's supposed to be fairly simple. Some of the best practices for it, just to get started, is I guess use roles so that you can organize things in a logical manner. So you group things like if you've got a common set of tasks that you do against every server, like set up Yum or update everything, put that in a common one, and then break it out by, like, if you've got a web server or a database servers, you can break it out into individual roles. Handlers are tasks that you would perform kind of repeatedly, things like restarting a service after changing the configuration, other things like that. You can put it at the end of a play so that once it runs through it, or after an individual play, you can put it at the bottom of it and it'll run it as soon as it's done and it completes it. And then also you can put in variables everywhere, so you can have like a set of group of variables at the top, and then sprinkle it throughout the playbook. So if you want to roll out like an app, you can have one single folder of variables you can edit, put in whatever variables you need for your area, and then just run the whole thing, and it'll go and build out, install everything for you. Put everything into Git, or mainly Git. Put it in version control so that people can edit it, roll it out. That becomes a lot more important with continuous deployment. Makes it so that you can notify things for if somebody pushes a change to a playbook, or if you're rolling out like a customized app, you can push out whenever somebody commits. You can rebuild everything and deploy it again. Use the documentation that's on their website. It's actually really, really good. It's a lot better than Chef and Puppet are the older versions of things. Salt's around the same age as Ansible, but the documentation, at least when I last checked it, like 6 months or a year ago, was a lot worse. It wasn't very easy to read or figure out what was going on. And then you want to use the Ansible modules that are available. There's probably a couple hundred at this point for doing everything from Yum, restarting services, apt-get, pip, gem, anything like that. You want to use the modules over running straight command or shell modules. That would basically be like running bash. The other good thing about Ansible that I believe Salt also does pretty well is it's omnipotent, I believe is how you say it. Basically, you can run a playbook, run it once, and then you can just keep running it over and over, and it won't make any changes if nothing's changed or if the configuration is how it's supposed to be, and then it'll quickly skip to the next piece. So that's why it's important to use the modules, because I think if you run straight command or shell, it'll probably just run it, and that might have some bad things that might happen. Anybody know anything about continuous integration or continuous deployment?
A small question.
Yeah.
How is this different from Python Fabric? Do you know Python Fabric?
I think is it called Funk? Or just Python Fabric?
Fabric.
Okay. I mean, I haven't heard anything about it. You can do it with anything. I don't know if that would be specific to Python, or is it just anything?
You can execute any SSH, basically.
Okay.
Python.
I haven't heard of it actually. I don't know. Do you know how old it is?
Mm-hmm.
Do you know how old it is?
It's very new actually.
Okay. I mean, this is written in Python. You don't need to know Python to use it. I'm not sure if you do for that.
Yeah, you need Python for that.
Or do you need to know how to know Python?
Yeah.
Okay. That's one of the other good things about this is from the beginning, the guy who made it, who worked at Red Hat, and he made a couple other utilities that you might have used. His whole goal with the whole project was basically, you don't need to know anything about this product. You basically just need to be able to write these simple English statements and run it, and you're good to go. He wanted to abstract as much of it away from you as possible, make it really easy to use. So I mean, that'd be one slight difference, is that you need to know Python to use Python Fabric. Well, continuous integration is building code whenever whenever there's a change. You can do it on a schedule, or you can do it on every commit. A lot of companies use it for managing large projects, that type of thing. Some of the products that do it are Jenkins is open source, Bamboo is a commercial product from Atlassian, and Travis CI is a web-based version that's, I think you give it any Git repository and it'll just run it whenever you get up to it. You like throw it in a queue. Jenkins is an open source continuous integration server. It's got a lot of plugins. It's really easy to use. It's kind of the standard for it. It has a lot of quirks though. So a lot of people like the commercial offerings a little bit better. Continuous deployment, on the other hand, is regularly pushing code through either QA, test, dev, or straight into production. Probably not straight into production, but regularly pushing it through all the way. I mean, we'll actually probably push to production a little bit. Deploys can occur on either on a schedule, like daily, or can do it as often as every time someone commits code. So I mean, there's companies like I think Airbnb and Facebook and that type of thing. They'll push out code to their sites every single day on a schedule, like every half hour. This is a good tool to do that as far as applications go. And Ansible and Salt and there's a couple other like specific tools for that. Ansible and Salt are more like configuration management and deployment type things. The team that I'm working on that I did this with, they're making an electric motorcycle. We needed something to collect metrics on a battery system. So we got a couple of software engineers making an application, and then our goal is to be deploying on every commit. So we're always just pushing the newest version of the application to the server we've got. So the workflow of that whole thing is code is pushed to Bitbucket, or you could do it with GitHub. Bitbucket or GitHub would notify the Jenkins server that a merge or push has occurred, and it would use something called a webhook. Basically, it's just a HTTP post, and it just tells the Jenkins server to pull the latest version of the code, do any set of actions, post, build, or pre-post or post before it tries to build the code or execute something, and then do some tasks after that. Our current application is written in Node.js, so it pulls the repo, executes an Ansible playbook that builds the app, and then deploys it to the machine. If any of the steps fail, the job fails and it doesn't deploy. So it first tries to build the Node application, and then if that fails, it won't push it to the production server, and hopefully we don't break everything. So I'm gonna show a little demo, I guess now. These are the steps, so you can basically do it yourself. So I've got Vagrant. Anybody used that before? It lets you easily recreate VMs. Basically type Vagrant init, and you get a Vagrant file. Describes some easy things like a base image to pull, perform actions, or you can put in like a Ansible playbook or a straight bash, and it'll run that. Do that all automatically, and then like a certain amount of time later, you'll have a VM ready to go, and you can go right into it. It kind of simplifies a lot of software engineering, and then it also simplifies this. Is that large enough or no?
A little bit bigger.
Oh, we can go back down later. Oh, that didn't help at all.
You do like Command Plus so it makes it bigger.
We're getting there.
That's weird. Just keep going.
There we go.
Vagrant. Oh, never mind. It's already up. It might take a second. There we go. I've got. That's weird. So here's the actual app we've got. I pulled it from our repo earlier today. I don't think they've made any changes lately. So I actually meant to show you. This first. So here's what that file I was showing earlier looks like. So you've got the name of it. You got hosts, whatever host you're running it against, or a group of hosts, whatever's in the host file, whatever user you're running it against.
You don't like hooks or jings too.
I'll get to that. This is just the playbook. Oh, I thought I deleted that. Oh, I guess not. No, I was testing that because could not get the GitHub hooks to work, or the Bitbucket hooks to work, and it turns out Jenkins had a security setting on that was blocking it.
Security.
Yeah, who needs it?
Nerds.
So if I go back up a little bit, go to the roles. So I've got a common one that I run, like a lot of common stuff that I do on any server, securing it, setting it up, configuring like NTP and a couple other things. We can look at what that looks like. Tasks are where you would put the actual things you're doing. So you've got the main one here. So turn off SE Linux because it's annoying. Update everything. Install the EPL release. NTP. I mean, this is how easy it's really easy to look, to do. Yum, name of the package you want, what state you want it in. So I think this one state's pretty standard across all the modules. Latest, it'll always update it to whatever's latest available. Present will just make sure it's there, or you can put, for what it's called, but you can basically remove it if you want to remove something. You can place files, like configuration files. It's got a templating language called Jenga. So you can make templated files that just list what variables you want changed, and it will only change that on the config file. Okay, I'll skip to that end. Tasks. Oh wait, actually, those handlers I was talking about are right there. So as soon as this goes through, it'll notify this thing to restart NTP. Go back up to common, go to handlers, and restart NTP, restart it, and you can just reuse that as you need it. Got a couple other roles for the front, for the pieces of the app we've got to install Mongo, a couple other things. Go back to this. The easiest, actually, I wrote down exactly what I wanted to do. Here's a simple example of it running. So this is just gonna run. Specifies Ansible to run on everything that's in the host file. I then override that anyways and just tell it to run it on the local host. Use a local connection and then use the module ping. That'll run, and that's a basic test you can do to test the connectivity with Ansible, make sure it's working. The next thing I was going to do, there it is, and then I'll just run this playbook that I've got. It's the same one we were just looking at. I'm just going to run it locally. So it just runs through all those things, configure all this stuff. So this a lot of this work was from when I was working at ITS. It changed manually configuring all any Linux servers that I did for doing testing out applications. It changed a process that took like an hour to configure a server from like installing it and then doing everything manually. Got it down to like 10 minutes. And I have to click one thing and then leave and come back when it's done. So this is the one of the verbose outputs of it. It doesn't look this messy other times.
While it's doing that, so you say it's a lot easier than Puppet. Would you say it has the same functionality then, too?
I think the main difference is Ansible is a lot better at orchestration, so like doing deploys and things like that, as far as I've seen. I know, doesn't Puppet do a lot better at, I think Puppet does a lot better at like ensuring things are in a certain state, kind of like GPOs.
I don't know too much about it. I know that they use it for deployment too. I just know Puppet's the one I was hear about, so it's a big one. So.
Man, I think they've got a lot in common. I like this one a lot better, and a lot of people are moving towards this because I know there's a lot of companies that like they'd had like an 8,000 or 10,000 line puppet configuration. Like that was everything was 8 or 10,000 lines, and when they redid it, refactored it into Ansible, it took like 1,000. And then, I mean, Puppet, you need to know the syntax and everything else, whereas this is fairly simple.
Yeah.
I know the only other, Salt's very similar to this. The only other thing I know that does better is it's a lot faster. Like, really fast.
Yeah.
Probably would have been done already. This one's a little bit simpler to pick up. I think that's going to fail, so whatever.
We are just about at time.
Yeah. Well, I would have shown the deploy on Jenkins, but I mean, this is what Jenkins looks like. If I did a push to the repository, this would get notified that it was running, or that something had changed, and it would just run that, and it would connect to the remote host and then deploy when it was done. That's about it. I like it a lot. I know my roommate used it at a company in Rochester. Changed a lot of their dev laptop. He like automated the whole thing, configuring the developers' laptops. So this slideshow should be available on Google. I think I sent you the link. So I mean, if you can post
put
it
up on our website.
Okay. Yeah, I added this during Bruce's presentation, but this is basically what you need to reproduce like an environment you can play with this in. There's like Ansible Galaxy you can pull things from. It's like a Git repository for roles and playbooks. That's about it. Metaquiver's next.
Alright, next up, we're gonna learn
Get into your time a little bit. Sorry about that.
Scapy.
Is there HTML for it to do that?
Yes, there is an HTML. It's just a cable, it doesn't work.
Okay, that's good. I don't need anything anyways, so, you know, I can get Scapy. I can just read you out my code. You'll understand, right?
Yeah, just read his code.
You'll be my interpreter.
Yeah.
Chromebook. Yeah. Best $100 I've ever wasted.
Yeah, Liberty Mutual tried to get me to convince them to use Chromebooks. I flipped that around to why you shouldn't use Chromebooks in an enterprise environment.
We don't start from
Because you're shit.
Level 1, plastic.
My favorite thing though is a laptop that requires internet. They don't have Ethernet ports. Yeah, because that's a sensible thing.
Rocket.
Give me 1 second. Because also it's. Well, I need a little more.
Got like MS Office?
No, I run a Chromebook, dude. I
Okay.
have MS Office.
Just giving you a hard time. Got it.
Don't understand my struggle.
All my packets.
Yes.
It's the most romantic thing I've ever seen.
70% button. Oh, look at that. Big button. Okay, so here to talk about Scapy. I'm Sean McConnell. I'm a third year ISF Ansible demo major. My life's really fun. I'm the tech lead for RC3. And small disclaimer number 1, I haven't done networking in like a year, so if I say anything that sounds really stupid or makes no sense or just wrong, please call me on it. And I'm sure one of you lovely people will know more than I do. Second disclaimer, a lot of this stuff in this talk and the tool in general can be used to do some very bad things. Don't do bad things because karma, and I don't want you guys to go to jail because, well, it will happen. Yeah, it'll happen basically. So don't do bad things, or bad things will happen to you. Anyways, let's start. So what is Scapy? It's basically a TCP IP stack built in Python. So, you know, you can craft, sniff, alter, send, and receive packets, all done in Python. And it does it incredibly well. There are a lot of other tools that allow you to do this, but none of them I've used have done it nearly as well as Scapy does. One of the main reasons I feel is because it follows protocol layering, which will make a lot more sense in a little bit. It has support for over 300 different protocols, and if there isn't one there, you can add it yourself, which is kind of neat. It can run in 2 different ways. It has an interpretive mode, like Python's interpreter, and you can also use it in Python scripts, which is where the real power comes from. They also have a little Wireshark support, so if you capture packets or build packets in Scapy, you can then open them and view them in Wireshark. And there's mmap support, so if you want to use mmaps like OS detection and fingerprinting engine, you can use that inside your Scapy scripts, which is pretty neat. So one argument that people say is, you know, why would I use Python? I can use C because I'm real hardcore like that. According to Sans, I stole this off Stackwell's slides. It takes 60 lines to write a single packet. In C, it takes 1 line with Scapy. Also, Python's way better than C. And then hping is a really cool tool. I've used it in the past. It saved me. But can anyone tell me what this command does? No.
I see a window size there.
I see windows.
Yeah, see, there's like maybe a window size, and you know maybe that dash S is the source port.
And a count of 1.
Yeah, so this is the same command done in Scapy. As you can see, there's a lovely destination. You're setting the ID. You're building a TCP packet with a source port and a destination port. It's a send packet. You're setting the window and sequence size. It's much more readable than other tools. Another big thing that I love is if you want to try and do stuff that these other tools like hping don't want you to do, you can't really build. I mean, maybe they have an API which lets you do a little more, but with Scapy, they're just like, here's the stack. Good luck. You can do so much crazy stuff. So honestly, Scapy really there isn't all that much to it. It's really just your understanding of networking. So we're going to walk through a couple examples. I figured a nice easy one to start with is ping. So in order to build ping, we kind of need to know how it works. I'm sure all you guys know how this works. So we know that according to our OSI model, we know it's ICMP protocol, and ICMP lives at layer 3 or 2, depending on your model. And we know that ICMP lives inside IP. So we need to build an IP packet with ICMP inside, and then we need to note that is a ping packet. And we can do this thanks to our friends at IANA that tell us that ping is denoted by a type 8 ICMP packet. So we need to build that. Okay, so now we have a little demo. Can you guys see this?
Yeah.
So you can start Scapy. It's going to yell at me because I don't have modules, but that's okay. So there are 2 big commands in Scapy, really. Like that's it. There's like lsc, and it will show you all the different functions that are built into Python or built into Scapy that you can use. And then there's the ls command, which will show you, right now it shows you all the different protocols that are supported. As you can see, there's like a ton of them. We don't need to see that. So the way this works, I'm sure you guys are familiar with object-oriented programming. So we're going to create an IP, we're going to have a variable called IP of the type IP. So this creates an object of the IP protocol. So if we do an ls of IP, it'll show us all the different fields that we can fill in, right, as you would for your regular packet. So all we're going to want to fill in right now is the destination, because, I mean, what else do we really need? So ls or ip.dest equals 162.243.254.242, which is my other box, which I forgot to start up. It's okay. How do I tmux?
TMUX?
Yo, really though?
Do you have tmux started?
Thanks. It's been a very long week. We're just gonna sh into tool, and we're just gonna use TCP dump. So we're checking for ICMP traffic on our destination host. So if we create our IP packet again, we say ip.dest equals. So now we need to create the ICMP side. So if we do ICMP equals ICMP packet, so if we do an ls of ICMP
you can see that there's a ton of different stuff, and it got cut off, but that doesn't matter because I'm bad at demos. We know that we need to assign the type for our ICMP packet as 8. Okay, so we now have our 2 parts of our packet. We need to combine them and then send them. So we're going to create another variable called packet, which I can't spell. So as I mentioned earlier, you do protocol layering, right? So all we're going to do is we're going to take our IP packet and we're going to put it on top of our ICMP packet. And now we have packets together and they're happy. So now we can send this with the send command.
So you said the type is for echo request?
Yes.
Okay. Because with ICMP, I think in Scapy it defaults to an echo request. So.
Yeah, so that's the other really cool thing. As you noticed, there were like tons of options that I was too lazy to fill out. Scapy will pick reasonable options for you. Like if you don't want to calculate your checksum, it'll do it for you because honestly I don't know how to do that.
But it's so much fun.
So we send our ping packet, and as you can see, we see it there. That's kind of neat. You can fill out other things. So if you did like ICMP.payload, we can set a payload of hi, I'm a payload, and then packet equals IB ICMP send packet. As you can see, our payload is right there. So you can specify like anything you want. Yeah, you can make really nasty packets too, which just mean you shouldn't do to anything you don't own. Send you to jail. Next thing I'm going to talk about is DNS reflection attacks. So I was going to show this off, and then I realized I don't own a DNS server, and I don't want to go to jail. So I have some code to show you how incredibly easy this is if you happen to own all the devices that's going to affect. So basically the way a DNS reflection attack works is you spoof DNS query packets and then you send them to DNS servers, and then it will send the response to the spoofed address. So if you say, oh, server, I'm Billy, and I want to know google.com, the server will go, oh, gee, thanks, man. Here's google.com. And then it will go to the real Billy and be like, hey, here's google.com. And then Billy will go, I don't really remember asking you this, but I mean, if you're telling me, I probably did. So it has to process each request that comes in. So if you send like 10,000 DNS queries to like 50 DNS servers, and they all send to your one little Billy, he's going to have a very bad day. So we're going to use some code. We can actually close all that. Yeah, we can cd Scapy. So this is an example of using Scapy in a script. So as you can see, you can use all the programming constructs of Python and with your Scapy. So you can do you can process all your packets and analyze it and make decisions, and then continue to do more stuff. So as you can see, this attack takes like 11 lines. Also, we're introducing a new sending function, that's the word, called sendpfast. So basically we're saying we want to send our DNS query 10,000 times over and loop that through 10 times. So we're sending like a shit ton of packets. Can I swear on your stream? I'm sorry.
Yeah.
Sorry, streamers. Anyways, so yeah, that's how you do that.
There are kids watching this.
I'm sorry, kids. Plug your ears. The other thing that I really wanted to do, but once again, I don't have infrastructure, was firewalking. I got to do this over co-op actually, and it's really cool. So basically the idea is if you are scanning a box and you want to tell if it's behind a NAT or a firewall or multiple firewalls, what you can do is you can find the minimum TTL to reach that service, and then you can keep increasing your TTL. And if it keeps increasing, then you know there are more boxes behind it, so then you know it's behind a NAT. So the code to do this is a little more complicated.
What company are you at?
I worked for Wayfair. They sell furniture online. Not a security company. They don't really... Yeah. I love you guys, Wayfair. You were great. You guys should all go work for Wayfair. They're a wonderful company. They treated me very well. So as you can tell, we can use Python structures and all that. You can make functions and Scapy works just right in. You just import it. It's pretty great. So I think this demonstrates really the power of Scapy. So we have a function that determines our minimum TTL. I'm really bad at naming things. I'm sorry. So here we're using the Scapy function SR1. So what this does is the send and receive function. So we're saying we're going to send this packet and we want to receive one response. So this allows us to find our minimum TTL. And then we're going to send a SYN packet. And this is the line in Scapy. Everything else is lovely Python. So once we do that, we keep on increasing the TTL to see if it gets any larger, and if it doesn't, then we know that our box is natted or not. This isn't the one that I thought it was, but that's okay. Sorry. Another cool thing that you can do with Scapy is you can build MAV functions. So if you really didn't like how something worked, you could just redo it. I don't know why. A learning experience, perhaps. We're not going to talk about these though, because they're all pretty simple. Also, one caveat to using Scapy is if you want to send any packets, you need to be root on your box. Otherwise, it's not going to work. Also, when doing things like this, when sending SYN scans in particular, so this is where I said my networking skills are very lackluster. I read on some sketchy like wannabe Stack Overflow site. So the issue is when you send a SYN packet with Scapy, your kernel will go and it will send a reset packet after it. So I read this is because Scapy sends raw packets. I don't know. But anyways, it doesn't send them using the kernel, right? It sends it doing itself, so the kernel flips out and it's like, whoa, sorry man, I didn't mean to send that. Just ignore it. So you have to set up firewall rules if you want to send SYN packets. Those are like the two caveats that I found using this tool. Other than that, it works pretty fantastically. The other thing we're going to look at, I think it's the last thing that I have, is we're going to look at how you can look through packets. Uh-oh. Oh well. So, ignore my very bad regexes. I found better ones later on Google. But basically what we're doing is I was given a PCAP and was told to find interesting things, and this was for a security class, so I assumed, oh, there's probably like web attacks or something bad happening, and it's like 40,000 lines, and I'm not going to sit there and look through all that. So I filtered out all the web traffic when it was still like a ton of work, and I'm like, never mind. So then I remembered I had Scapy on my box, and I wrote a little script. So it extracts the payload of all your web traffic, and then it compares it against a regex. And then if something gets flagged, it prints out the packet, so then you know, oh, hey, this was probably a web attack, and it's probably a bad thing. So that's one thing that I used Scapy for that I thought was really neat. Sorry for my bad programming. Yeah, anyways. Scapy's really cool. It's very powerful. You can do just crazy amounts of stuff with it. Yeah, so that was my conclusion that I just said. In conclusion, you guys should all use Scapy. It's really powerful. I probably haven't done it justice, but you can do some really crazy stuff with it. Anything you want. Use Scapy. Any questions? Yes.
So you mentioned sending out a DNS request to like whatever DNS server. What's the difference between that and just sending like a fake reply to that to Billy?
So that was the other thing I wanted to do, and once again, I don't have infrastructure set up. I sat there on DigitalOcean for like 2 hours trying to build LANs or get two boxes on the same LAN. Doesn't work, by the way. So what you can do, that's more of like DNS spoofing. So you can, with Scapy, you can sit there and sniff traffic just like on Wireshark. So you can sit there and look for DNS requests to go out on your network, and then you can, once they go out, you can rebuild a reply based off their request and send it to them before the DNS server gets back. So then they will use that as their, so you can do like man-in-the-middle attacks, and you can redirect them to like bad sites and stuff. It's pretty cool, which you all shouldn't do unless, you know, it's in a lab environment and you own the machines.
What I mean is like, if the purpose was to just make the release day really bad because you just got 10,000 packets from a DNS server, why don't you just send them those 10,000 packets so they can stay bad?
Because
why do you have to ask someone else to send them?
Because, well, I mean, you could, but then you're sending the packets, and then it comes back to you.
Can you change the source IP with Scapy?
You probably could. Yeah, I know you can.
That's how you did the other one, I thought.
Yeah, so you can specify like a source address, and you can like spoof, so all your packets going to you or sent from you, and makes you have a really bad headache when you're staring at captures, getting confused. You could do it that way. I know that you do this with DNS, NTP, SNMP, and stuff like that. It was what was used during the when they took Xbox Live and PSN down. This is how they did it. I'm sure you could do it that way. I think the way it works though is your DNS servers probably can send the packets out faster or something like that. Any other questions? Or any comments correcting me? So
Yeah, I mean, that's the reflection part of it, is that you can basically get 5 other terribly configured DNS servers to all blast somebody. And they're probably a lot more powerful than whatever you're using.
Yeah, also that's the other thing when you're trying to do DNS reflection attacks, don't just like hit random boxes on the internet that you know are running DNS, because they have to be misconfigured to use recursion improperly to allow reflection attacks. Otherwise you're just sending stupid queries to a DNS box. And hoping you never go. Yeah, don't do that. But anyways, it's my presentation for today.
Oh, look aloud. Cool. Why is riverbed modeler open? Nope. Not even close. Well, that's shitty. Alright. Hi, friends and neighbors. My name is Nathan Lichtenstein, a third-year networking and systems administration student, also the president of this ragtag team of losers called NextHop. Just kidding, that was mainly geared at Bruce. Kidding again. So just to wrap up the evening, I'm going to kind of dumb it down a little bit from the more higher level topics, and we're going to then ramp it back up again. At the end, we're going to talk about Linux file permissions. So the basics, for those who are not familiar. Pick a directory, any directory. So the basic goal that I want to kind of get across is what a Linux file permission structure is going to look like. So if we just went to any random directory on a Linux box, we issued an ls-l, which is a long listing. And I only had one thing in the directory, maybe of something called like myfile.txt up there. You'll get a permissions return on it, and in order, these are what all the different fields mean. The one I want to focus on primarily is file permissions, owner name, and the owner group. So it's broken up into three-part segments, plus one blank flag field at the beginning that indicates if it's a directory or a file. So if your flag at the beginning is blank like this, that means it's a file. If there's a letter D there, that means it is a directory. So the first three indicates that the owner of the file, or me, Nathan, has RWX, read, write, and execute, which we'll talk about a little bit more as we go on. Moving over to the next group, has RWX again. That means the group, which is in this field right here, has again read, write, and execute. And then there are 3 dashes at the end, which means that the other category has absolutely no permissions at all. So with that in mind, we'll move on. 3 commands you can use to modify this are chown, chgrp, and chmod. First one, chown or chown, changes the owner of a file. chgrp changes the group that owns the file. And then chmod is what you can use to start to change the permissions. Permissions are done in both relative and absolute format. We're going to talk about them absolutely using numerics. If you break down to 3 categories, you have 4, 2, and 1. So if you've ever gone to change a file permission in Linux and you've done chmod 777, then your file name, you're probably going to have a bad day because you've just granted everyone in the entire world read, write, and execute permissions. I kind of broke down what that means in regards to files or directories. If you have read on directory, you can list contents. Write means you can add a file. Execute means you can cd or change into that directory. On a file, read means you can open it only. If you've ever been doing anything like DNS setup or DHCP setup in CentOS and you open up a file in Vim and then you spend like your entire life writing it and then discover you opened it in read-only mode and you don't feel like remembering how to fix that, you probably know the pain there. On a file, that means you can modify it, and execute means you can run that script. You can run that as a script, which we'll get into when we talk about the SUIG, the SGID, and the sticky bit. Those are flags you can set at the end of a chmod. So the first one, SUID, is indicated with a U plus an S. That means that the user will execute that file with the permissions of the owner. So if we go back to that example at the beginning, where the user had read, write, and execute, that means if someone who is not me tried to use that file and I have that execute permission, I could have like something called like virus.sh because everyone names their virus files really obviously. So that means anybody could, if they knew the path to that file, get to it and run it as if it were me and blow up my machine. The same concept then applies to the SGID, and then the sticky bit only prevents users from deleting other users' files. A nice thing about SGID, which I have used for in other applications, which we'll kind of go into for a demo in a little bit, is that it ensures that files created in the directory get the same group owner as the parent. So, the problem with Linux file permissions, did a nice little quote here. The way Linux works with permissions, it does not allow you to give permissions to more than one user or more than one group, which a lot of people view, myself included, as a shortcoming of dealing with Linux file permissions, because unlike Windows, where you can right-click and you get that nice permissions menu, and you can put up 100 different groups and users that can do different things, with Linux, it's usually saying, it's my way or you're shit out of luck. Well, that's not always the case, I found out. Linux actually has something called ACLs, or Access Control Lists. For my purposes, I'm just talking about it from a RHEL, or Red Hat Enterprise Linux standpoint. ACLs are going to allow you to find multiple users and multiple groups on a file, which is really handy for things like role-based systems administration or action-based systems administration. And it also lets you set inherited default groups. So setting ACLs is relatively simple. All you need to do is issue a set FACL, or set a file ACL. I personally have always called it a FACL because I like to sound out my words. That's how you set it, or you can do a get FACL and you can pull it back out. The syntax is really easy. You just do set FACL, -m means modify, so you add on, and you can do D, default, G, group, the group that I'm going for, and then their permissions in a relative format, so with letters. Or you can, if you don't have a group specified, you just do double colons to skip over that field. So, I kind of want to talk about why I had to get into this. So I am the resident systems administrator for Reporter Magazine. When I started there, this is my super secret username, sysadmin. Oh, damn it! Cool. That.
Oh god. Unplug replug.
Push auto sync.
Unplug replug.
Is there an auto sync button?
Just auto
That do something?
Yes.
Yes.
Replug's more fun.
Cool. So when I started at Reporter Magazine about 18 months ago, We were running our file server off of a lone Mac Pro purchased by Reporter in 2003. It had a 250 gigabyte non-redundant hard drive, and we were pumping our magazine into that. Everyone shared one user account. That was the really fun part, too. And the password was like Reporter, but you replaced the E's with 3s. That's what I walked into. After I walked out, threw up, and came back in, I said, let's get our shit together. So we bought a new, I got a nice budget, we built a new file server, and I soon discovered that trying to manage permissions with all these users was really crappy in Linux because there was no main permission structure, and we didn't have it in the budget to buy an actual license for Windows, nor was I giving up one of mine, because I'm selfish. So we came up with pretty elegant solution. So I just did an ls-l, which shows you everything there. So these are the shares that we use to operate in Reporters. Ooh, that is ugly.
Yeah, dark blue.
Dark blue.
Color scheme.
Can you make that
Who
bigger?
remembers that command?
I don't know. Can you make that bigger?
Yeah.
To change the color scheme.
I don't know how to make it bigger in Putty. Who knows?
Oh, options. Change settings.
Eh?
This one.
Change settings.
Oh, you gotta do it.
Oh god, I don't know what's happening. I need an adult. Window. I'm trying to make the font bigger. Hold on.
It's like now hidden behind the
It's fine. I got this. We're going to crank that up to like 24 point.
Now Grandpa can see.
That didn't make it any better. I think I just made it progressively worse. We're going to try this.
James, if you're watching,
James.
you should be able to see now. Oh god.
Hold on.
Finally. He hasn't started streaming.
That really isn't much better. Let's see.
That's better.
Okay, that is a lot better. Cool. P-box. We'll just go through it this way. So we have all these different file structures that we use here. Our biggest one is the Art Dropbox. That's where I have a ton of users constantly coming in. We also have our business share, our e-board share, our EIC share, which I insist people use, but they never listen to their systems administrator, and then they complain to me when they delete it. And I really hope no one from work is watching this right now, nor would they be. We have the print share, which is another really big one, as well as stuff for video. So we handle a lot of users. All in all, I have about 60 people that I am working with constantly. So as I said, the biggest problem being, I kind of go for that role-based administration structure, where I don't want to say, okay, I'm going to make a group called Reporter File Users, and I'm going to grant you that when you go to hook it with SMB, you can get into my tech share and you can get my database files, or you can go to the EIC share and see who she's going to be firing this month, or you can go into any one of, I wish she would use the share. Yeah, if she went to, you can go into one of any millions of places and get all these permissions. And yes, that's craftable a little bit more with Samba, but come the day when I teach them how to use SSH, I really don't want people going everywhere, because that's a really bad idea. As Hartpence would say, it goes blah like that, and there's traffic all over the place, and it's a mess. So that's where file ACLs have come in, because there are people that I need to be able to go everywhere. Those are people like me, the administrators, who need to be able to go, oh, you deleted something, there's a hidden recycle bin in there. Let me get in there. So what's a file ACL setup look like for us? So if I do, first of all, let's clear the screen. If we do a get FACL, I want to look at, let's say, the Art Dropbox. So we can see a couple different things here. All the way at the top file is the Art Dropbox. The owner is this great dummy account, very creatively named Reporter. Breaking down, you have the group. So anybody, any of my new users that I bring into the system that are artists or designers or photographers or illustrators, I automatically give them, first of all, I throw their home directory to sbin no login, just to make sure they cannot ever SSH into the file server, because that is a terrible idea. Moving past that, they all get one group and one group only. Reporter Art Dropbox, which entitles them access to one folder and one folder only, which is here. But as I said earlier, the admins need to be able to get in too. And if I'm locking that down with traditional file structures, that means I'm making the group owned by one person, and then I'd have to do overriding permissions, or God forbid, other permissions, and letting people in. So that's where ACLs come in. Because I can set a default group, which is admins, which can do whatever the hell they want. I can even set a default group do the Dropbox, which is recursive, so it pushes down. So you get a very similar functionality to Windows. Now, the only place where this can kind of be a pitfall is that if you are creating things directly from the shell, so if you're creating additional files and folders, it will only tack on additional users, like defaults. It will still follow the traditional Linux file model of the owner of the group, the group file owner being the primary group of the creator, and the owner being the account that has created it. But there are some clever ways to work around that with Samba.
How are they accessing this stuff?
Currently through this really cute program I wrote, which is actually a compiled ini file, or a bash script. I don't remember what it is.
I was going to say, if you got them logging in and doing things through Linux directly, good on you.
I have them, I wrote this really cute little file thing here. It's the reporter share connector. And all my users do. It's really great. They come in and they go, oh, I'm a technology person. And they press 5. And then I have a script that just guides them through the Samba process, slowly but surely. And in the end, you have, it opens up a little window over here and it mounts it. It's adorable. And then when you're done, you come in here and you press any key to disconnect. You hit yes, and it closes the connection via Samba, which will hopefully be the topic of Tech Talk 2, Linux and Samba. So this is kind of the base for what I hope to talk about more in the future. So it's really useful to do with file permissioning in Linux. A lot of people tend to shy away from Linux when it comes to their personal file shares and structures because permissioning, quite frankly, can be a bitch sometimes. But file ACLs definitely make your life a little bit easier. Especially implementing the G+S bit is a very handy one because it at least makes sure at a minimum that your grouping is staying consistent at the end, so you're not losing any permissions that way. Awesome, exactly 9 o'clock, just as I planned it. Any questions, comments, concerns, thoughts, feelings, emotions, or if you just want an autograph, go.
What happens if you close the program that you wrote before they say, yeah, I want to close it?
It does not let you. I know you. So the first rule, obviously, of systems administration is what? Users are stupid.
Yeah.
So,
That's exactly what I was
so my emergency plan, and this is totally off topic of what I planned on sharing, but my emergency plan goes something like this. If I log in as my shining self, and it mounts the tech share cleverly to drive T for tech. Each share goes to the first letter, what it's called, because again, I work with a lot of people who don't mount a lot of shares frequently. So if I close that out, it's still mounted, so you can go back. But let's say I have someone editing a file, and they're like, oh, I'm done, and they smash their keyboard, and it actually hits a key. And it's like, are you sure you want to disconnect? So I have the failsafe in there, and I'm like, ah, crap, no. Oh, wait, I'm done. No, I'm not. So I just boot loop it all the way through.
I think somebody can close the
Yeah, what if you close it?
Oh.
That one or?
Oh.
That is still there, and it still stays mounted because I'm not that clever. But I figured by scaring users, it scares people into submission sometimes. So any other questions about ACLs, file permissioning, my dating life, really whatever we want to talk about.
When are you getting married?
October 17th. Cool. Well, thank you, folks, for making our first non-build it night a successful event. Show of thumbs up or thumbs down. Who would come to another one of these? Awesome. I'm really glad we got Bruce Hartpence to come, so thanks to him.
Come again, 'cause that was great.
Hartpence is one of the most fun people to listen lecture. He has the best voices and the best bodily expressive movements. Feel free to check us out on the interwebs at NextHop.network. We were on a waiting list for the .network domain for a while, so we got one. I'll pull up the website. I'll do a shameless plug to what Bruce and I did one Saturday night with our thriving social lives. Hold on, that's my face! Go.
Okay. Pull up yourself in the live stream.
Oh my god, no.
Oh, can we Inception this?
Yeah, Inception.
So go to the NextHop website. I had a graphic designer friend who owed me a favor, so that's how we got the logo. Feel free to take one of the stickers.
Should we all email the club office?
Yeah, and tell the club office that we are a club. So email the club's office and tell them we want NextHop because they still don't think there's a need. Someone sent me a thumbs up. Hi. Watching the live stream.
They think we're the same as the web dev.
They think we're the same as the Web Dev Club because we have a website.
Supposedly our PO went through today, so don't send any angry emails until next week.
Not yet. But
Make a post in the Facebook group.
sign up for the mailing list. Check here for events. We're hoping to do events like every other week. That way we don't overload your lives with networking, but don't let you forget that you love networking. So sign up if you want to give a talk. No judgment, no public speaking experience required. And if you're not here, we can go super meta and look at the live stream. I don't know what this is going to do to the world. Like, whoa, this is really laggy.
Oh, yeah.
It's super laggy.
Super
Yeah.
delayed. Just wait.
Super delayed. I don't want to watch myself talk. So anyway, thank you all for coming. Grab last bit of food, and we'll be emailing you with an exit survey. And thank Bruce Hartpence next time you see him for giving us his time.
If you didn't sign
Thank you,
sign
folks.
in for it,
Have a great night.